Hi friends, welcome to the next episode of GIS for Smart Governance. This episode has been named as Sow and Reap Digitally. It is the application of geoinformatics technology in agriculture sector. So, we will see how the technology can be utilized in agriculture. This episode in the series tries to explain the application of geoinformatics technology in natural resource management with particular reference to agriculture. We know that agriculture is very much related to natural resources, and the application of natural resource management is very much related to agriculture also. The proper application of natural resources, especially like water and other resources which are available or which makes agriculture possible in any terrain, that is very much related, and the proper application of the technology is also very much essential as far as agriculture is concerned. So, that is what we will be examining, we will be trying in this episode. So, satellite remote sensing and geographic information system offer great promise for natural resource management with the ability to depict the spatial distribution of the extent and monitoring capability. So, there are two things which has to be taken into consideration, that is the application, the capability of the system, capability of the GIS for natural resource management because of its ability to depict the spatial distribution of the extent and monitoring capability. So, two things are there. One is just like the main capability of any GIS is that the spatial data management. So, the spatial distribution of agriculture is very important, and its that is the extent up to which it can be there. So, that is one, and also the second thing is the monitoring capability of the GIS. So, these two things make it important to use GIS for any agricultural related activities. So, these technologies, these techniques have potential to predict and sonate different levels of crop response to the inputs and can also provide solutions to various management problems in increasing the performance of the cropping system in a spatial and temporal dimension when coupled with the relevant ancillary information. So, there are three things that we have to be careful about when we use this technology for agriculture purposes. That is, one is that the capability or the potentials of the technique to predict and sonate different levels of crop response to the inputs. How the crop responds to different inputs, say it can be water, it can be the difference in soil, it can be the fertilizer that has been applied to the field, and also the system can provide solutions to various management problems. It may include even the control of pest also in the field, and also in increasing the performance of the cropping system. Then how we can increase the performance of the cropping system in a spatial and temporal dimension. So, what do we mean by that? Spatial and temporal dimension means, that is, we know that in any agricultural field it is not mandatory that all the area is having the same soil type and all the area is having the same slope and all the area is getting same kind of water, let it be irrigation from groundwater or surface water. So, this will vary in time and space. So, that spatial and temporal variations can be easily distinguished and that can be easily mapped by using a GIS technology. So, this when coupled with relevant the supplementary informations like other that is, what are all the pesticides used, what are all the that is, how was the field before, and is there any difference in the nature of the soil when you add the ancillary information like soil chemistry, and is there any problem with the water that has been used for irrigation, like that. So, this spatial and temporal dimension, it is added and the ancillary information is added. So, all this kind of analysis is possible with the GIS, and a suitable blend of these technologies aid in efficient management of our resources to enhance the crop productivity on a sustainable basis. That is also important. That is, these technologies aid in efficient management of our resources to enhance the crop productivity. It is not that always, that is, we do not have resources, but the efficient application of the same, that will enhance the productivity. So, that can also be done if we are using that in a proper way, and not we have to say it is not proper way, it is on a sustainable basis we have to use that, so that the productivity of agriculture will be increased. We can be sure that the resources has been utilized in a sustainable basis. The first thing is the crop inventory, how far we can use that. That is, how do we use this technology for crop inventory. So, the first thing is that the remote sensing the capacity of the remote sensing technology and also the different sensors or their intrinsic ability of spectral reflectance data to identify and distinguish crops is very helpful in deriving crop acreages, production estimates, to monitor and assess the crop condition. So, we have to see how it is possible or what is the upper hand of this remote sensing technology for crop inventory. So, there we have a term that is called spectral reflectance. It is nothing but the response of the material which is being sensed by the sensors or the remote sensors. So, how it reflects. So, the spectral reflectance curve, we call that in remote sensing terminology, that spectral reflectance is different for soil, water, snow and ice. So, depending upon the material which is reflecting back the spectra. So, that is the spectral reflectance curve will be different. So, depending upon that we can easily distinguish from an image which area is covered by sand, which is covered by vegetation, like that. That spectral reflectance curve, that spectral reflectance data will be different for different crops or different for different vegetation. So, with that capacity we can identify and distinguish crops, and that that application is used in deriving crop acreages. So, what much crop is available, what much crop is in good condition, or what much area is covered by healthy crop, like that. So, production estimates can be easily done or production estimates can be forecasted, and then the monitoring of that can also be done on a timely basis. So, this kind of crop inventory can be easily done with this, the application of the spectral reflectance data in the agriculture fields. Then remote sensing based crop identification and discrimination is centered around the concept that each crop has a unique spectral signature. So, just like the spectral reflectance curve. So, we have each crop, that is each material we can say, and in the case of agriculture if we say each crop has a unique spectral signature due to its own architecture, growing period, etc. So, with that we can identify easily distinguish. So, if we are having an image of a plantation which may be having different crops. So, with the spectral reflectance, the spectral nature of the spectral signature, we can easily distinguish between the crops. But there are chances that when two crops with similar spectral signatures occur in a given date, we are getting the data, but they are showing very much similar spectral signature. So, distinguishing between these two will be slightly difficult. So, in that case we may need multi-date data. So, the growth rate of the two will be different. So, we can easily distinguish if we are having the multi-date data, that is the data of the same area, but that has been taken on two different dates, two or more dates. So, in that case we can easily distinguish between the crops, but again we are utilizing the spectral reflectance or spectral signature of the material or the crop. And then for acreage estimation, so we are using the we are utilizing the technology for acreage estimation. That procedure involves a 5-step procedure. So, the first thing is that selection of single date data that corresponding to the maximum vegetative growth stage of crop. So, that is important because we will be taking, that is the maximum vegetative growth stage of a crop has come. So, we have to make it sure. So, selection of single date data, because the satellites will be rotating around the earth, the earth resource satellites or the polar satellites, they will be rotating around, revolving around the earth. So, we have to select a particular date. So, that corresponds to the maximum vegetative growth stage of crop, that is the first step. Then identification of representative sites of various crops and their heterogeneity on image based on ground truth. So, just by looking at the crops, just by looking at the images, we cannot exactly say that this area is covered by this particular crop. For that ground, we call that as the ground truth verification or field verification is also necessary. So, that and then we will identify certain representative sites, say for this particular crop this much area or this site will be used as a representative site for that particular crop. Then for another crop another area will be taken, and that will be verified by going to the field or by ground truth verification. And in the third step, generation of representative signatures for the training sites. The sites we have identified and that is called the training sites, and then generation of representative signatures for the training sites. What response has been given by this particular site, how this particular crop is giving response to the spectra. So, that will be identified, representative signatures will be identified. So, that is the third step. And in the fourth step, the classification of image using training statistics. So that is that can be done in two ways, that is that is supervised classification is there and unsupervised classification is also there, and that will be taken care of by the image processing softwares which are plenty now, and that will be done through using softwares. So that classification is done in the fourth stage of acreage estimation, and in the fifth stage or the last stage, estimation of area of the crop using administrative boundary like district mask, or how do we want, that is whether we want it for taluk wise or panchayat wise, or how do we want, or if it is required for individual persons plot or individual persons acreage, how it is necessary. So that will be taken, or that will be taken care of, or I mean that can be demarcated. So in this way the acreage estimation of crops will be done. So that is how the remote sensing technology is utilized in acreage estimation. Then another area where this technology is utilized successfully is the cropping system analysis. Because so why this is the remote sensing technology is utilized for cropping system analysis, that we will examine now. That is, remote sensing provides valuable information on the distribution and condition of crops at different spatial hierarchies and has the highest compatibility for analysis in GIS environment. We have seen so far that GIS and remote sensing, and the remote sensing data is very much suitable for digitally working on, and GIS environment is utilizing that capacity, I mean that data very much, and so remote sensing provides valuable information on the distribution and condition of crops at different spatial hierarchies. However, how do we want? So we can get that in with respective hierarchies, and that has the highest compatibility for analysis in GIS environment. So that will be utilized. Then information on other natural resources that are of significant importance towards agriculture production can be integrated to generate information for sustainable agriculture. So for example, we have identified that certain area is occupied by the rubber plantation. So what are all the parameters that require a healthy growth of rubber plantation? So we know that is the water is required, slope is required, the rainfall is required. So what are all the parameters, what are all the natural resources? So we can make thematic maps or thematic layers of that parameters, then we can combine that. Then we can have a model, that is if the conditions are like this, what will be the growth rate. Then we can calibrate that model with the available satellite images. Say 1 month before, how was the growth rate, now how it is. So in this way, if it goes, how it will be in future. So here we are actually merging together different themes. So that will be including the natural resources. So in that way, the natural resources, the themes of natural resources as well as the crops, the data on crops are also merged or that are blended together. So we can get an idea, and they are integrated together to generate information for sustainable agriculture. Now we will see how this technology can be used for production estimation. So in that case, we will see how crop yield is influenced. What are all the factors that influence crop yield? So these factors will include genotype, soil characteristics, cultural practices adopted, and meteorological conditions, and influence of pests and diseases. So that means there are many factors that include that influence the crop yield. So the crop yield is something that is influenced by or significantly influenced by many factors, and the spectral data of a crop which we get from remote sensing technology is the integration of all these parameters that we have seen. Spectral data of a crop is the integrated manifestation of the effect of all these factors, that is it will be represented by, or the spectra will be influenced by the genotype, the nature of the soil where this particular crop is grown, and the cultural practices adopted, like that. So the spectral response curve or the spectral signature, what we call that, so that is a result of all this. It is not just because it is the response from a particular leaf of a crop. So all this will be reflected in that. So development of reliable crop yield models with minimal data is a major thrust area now, because we will not be always, it will not be possible to get all these data in order to model the production estimation, in order to identify or in order to calculate the production, how much production will be there. But with the minimum data set, how we can model that in a successful way, that is another challenging area as far as the application of geoinformatics technology for agriculture is concerned. That is, major research is being done on that area also. And a major challenge often confronted in agricultural crop production despite the development of advanced agricultural technology is the damage caused to agricultural crops by pests and diseases. So, we have seen that the crop yield is also influenced by the pests and diseases. So, the major challenge that is in agricultural crop production is also that. So, definitely we have to understand that. So, crop losses can be due to biotic factors like pests, diseases, weeds, and abiotic factors like flood, drought, cyclones, hailstorms, etc. So, the problem is that damage is known only after considerable damage has been occurred. So, this damage is known only after considerable damage has been occurred. That is the major problem now. So, the reason is, so now this is the point where the technology can be utilized, whether when the damage starts or when the weeds or the pests starts to spoil the crop, can we identify that? That is, at the beginning itself, if we could control that, whether the technology can be utilized for that purpose. So, that is the question. So, statistical, meteorological or spectral models are used for crop yield estimation. So, we have seen that is statistical, meteorological, and sometimes spectral models are also added with that, or sometimes spectral models are seen separately. So, they are all used for crop yield estimation. Remote sensing based models adopt two approaches. There are two approaches which are used. One is single date spectral index and second is multi-date spectral index. That is the growth profile, multi-date spectral index growth profile and single date spectral index growth profile. So, the single date data, that is a single date data spectral index, that approach relies solely upon the data acquisition within a narrow critical period of maximum vegetation growth phase, while multi-date approach depends spectral data at different stages of crop growth within the seasons. That is, there are two things, that is, these two approaches are utilizing two different data sets. First thing is the single date data, that is single date data spectral index approach, that relies only on single data set, that is the data acquisition within a narrow critical period of maximum vegetation growth, that is in a particular season when there has been maximum vegetation growth. So, that particular day, that will be a particular day, so that data is captured and that is utilized, while multi-date approach depends spectral data at different stages of crop growth within the season. So, spectral data, that is multi-date data set or multi-temporal data set is used in the second approach. But there are challenges also, that is when we use both the techniques there are challenges. So, especially in the case of the multi-date approach, the constraint of obtaining the cloud free multi-temporal satellite data within the crop growth cycle, that is an important challenge, or that is a major challenge, that is we have to get multi-date data sets, but all the time when the satellite will be passing over the area. So, without clouds, without cloud cover, we have to get the data. So, that is a major challenge. And nowadays, to overcome this problem, what is being done is the microwave data is being used. So, the microwave data has got that advantage that irrespective of the season, irrespective of the climate, irrespective of the time, that is whether it is night or day, that microwave data can penetrate and the data can be, the microwave can be penetrated into this system, and that will be backscattered and that will be recorded by the sensor. So, that we will be getting the data, the data will be getting recorded, the information will be available. So, the all weather and cloud penetrating capability of the microwaves are being utilized now, and remotely sensed data directly or its derived parameters are related to the yield or to the biometric parameters. That is, the directly or its derived parameters are related to the yield, we have seen that, or to the biometric parameters. So, the remotely sensed, so when we say that we are using remotely sensed data, which is actually the reflection of the biometric parameters, and also that will be helping in identifying the crop yield. Then another area where we will be utilizing this is crop monitoring and condition assessment. So, how we can see that? Condition of the crop is affected by factors such as availability of water and nutrients, pest attack, disease outbreak and weather conditions. So, that will be reflected in the condition of the crop. So, that can be easily identified in the image or the what do you call the sensed data set. So, what are all the things that the factors that will be affecting that, or which will be reflected in the data set, such as the availability of water and nutrients, pest attack, disease outbreak and weather conditions also. These stresses cause physiological changes which alter the optical and thermal properties of the leaves and bring about the changes in canopy geometry and reflectance or emission. That means these are the things that is being measured. So it is that. So how it is, how the energy is reflected or emitted from the surface. So when we measure that or when we record that, we will get an idea about what is the nature of this particular leaf or the vegetation canopy of which is being recorded. So we will be getting an idea about the stresses which are causing these physiological changes to the leaves. Monitoring and assessment of crop condition at regular intervals during the crop growth cycle is essential to take appropriate curative measures and to assess the probable loss in production. That is, continuous monitoring is required, continuous recording of the information, and so then only we can go for curative steps, so that we can say, just like the pest attack is there. So in one imagery of a particular date, we have seen that pests have started attacking the crop in a particular area. So definitely the field visit is required, pesticides have to be applied, so that we can check that the spread of that pest to further areas that can be checked. So field verification is required, continuous monitoring is required, but the entire synoptic view of the entire field is easily available by when we use the image, that is satellite image. Regular monitoring of satellite data on crops at different phases of the crop growth that would reveal any departure from normal growth for inferring occurrence of any anomalies to incidence of pest and disease damage with the support of ground observation. So that is regular monitoring is a must. So we have, that is, if it is healthy growth is there, so that will be giving a particular signature. But if it is not there, if it is showing some anomalies, we can definitely suspect that there is some kind of pest attack or some kind of problem is going on in that particular area. So that can be addressed. So that will help in addressing the pest attack or whatever it is. Sometimes it may be that the water is not getting properly into that area, or sometimes there may be other factors that will be affecting the crop yield. So that can be addressed. So in view of large area coverage in a short time and of repetitive nature, remote sensing techniques, if used in complementary to the ground surveys, it can provide real-time data for early detection and warning of outbreak of the disease or insect damage before they reach higher severity levels. That is, we can control them, that is, we can cure them at the lower levels itself, so that it is not affecting large areas and large amount of crop is not being lost. So that can be done if if continuous monitoring is being carried out in these areas. Then the developments in the satellite meteorology has enabled the retrieval of basic agrometeorology parameters like cloud cover, albedo, solar radiation, surface temperature, air temperature, rainfall, absorbed photosynthetically active radiation, soil moisture and evapotranspiration, etc., which contribute significantly to the understanding of agricultural production forecasting. So think about the parameters that we have listed now. So that is all these parameters which required otherwise a field monitoring, field measurement, but now everything is possible remotely sensing. Especially meteorological satellites are providing on a daily basis, or some say 12-hour basis or 6-hour basis. How do we want that this kind of analysis, that is cloud cover? So for how many hours the entire area will be under cloud cover? What is the albedo percentage? What is the nature of the amount of solar radiation, surface temperature, air temperature, then the rainfall, absorbed photosynthetically active radiation, like that many parameters which otherwise required field monitoring and field measurement, now we are getting that in a telemetric way. So that is another important aspect. So when we can add these meteorological parameters together with the ground measurements, I mean ground measurement in the sense what is the irrigation potential, how much area has been irrigated, and then the biometric details, like the biotic details like the pests and nature of pests and all. So we can combine all this information together, and then combine all, that is, these details are combined together, and that can be disseminated to the farmers also. That is important. So it is not that getting all the information and keeping that in the research centers, not like that. It has to be communicated, it has to be disseminated into the real needy people who are working with the fields, that is the farmers. It can be a single farmer or a group of farmers who are working with the crops. So it can be disseminated. So online applications have been already started by the government and different state governments in India. So one such application is the Ikedat web portal that has been started, that is online applications of farmers through Ikedat web portal. So for that, how the farmers are eligible, getting eligible for that different schemes in agriculture, that is eligibility through another portal is there, the land records or the E-Dara portal is there. Then field wise suitability and approval based on 2D or 3D satellite image interpretation, that is when the farmers are applying through this kind of schemes or online. So field wise suitability and approval, that is whether in this particular area this crop can be grown. So that will be, that is the agricultural scientists and remote sensing technology, that the agricultural scientists will be utilizing the technology, and they will say whether this particular crop can be grown in this particular area during this particular season. So then they can go with that advice, and whether there are chances that there is a drought is imminent in this particular area. So you should not go for a crop which is in need of large amount of water. You should not go for that. So that information can be obtained by the farmers. So in this way technology is disseminated. And post execution evaluation through satellite image interpretation, that is also there. Post execution evaluation, that is once the crop has been done, so that is following the advice given by the scientists and all. So how far it is okay, so whether that was okay or whether the model was correct and all, that can also be done. And then another area is that water is a basic need for any kind of harvesting and agriculture. So water harvesting structure, that is how to construct, what are the points or what are the areas, the locations where water harvesting structure can be made. So that water harvesting structure decision support system is also in place now. GIS based water harvesting structure decision support system, that is also in place, so that farmers can go for different types of structures which are already available, but it is not advisable to make all structures everywhere. But there are certain, that is some area may be suitable for only rain pits, in some areas some trenches may be advisable, in some areas some subsurface dikes may be required. So depending upon the geology and meteorology, the farmers will be advised you make this kind of structures, so that the water harvesting will be in a, that is water harvesting can be done in a good, that is in a better way. So that will be followed, and so they are getting a decision support system in that way. Then what are all the other applications, that is so that we can utilize this technology? One is the identification of location for soil sample collection. So in order to understand the nature, that is the fertility of the soil in a farm or in a field. So what are all the areas for identifying the location for soil sample collection? It is not that from every point you have to collect. There are certain statistical methods and there are certain agronomical practices that we have to follow in collecting the samples. So that will be advised, or that will be given to the farmers, and then that is the latitude, longitude, or we can say the location of the places from where the samples have been collected, that will also be noted. So that that is a scientific way, in a scientific manner the study can be compiled together. Then identifying the soil parameters, that is including the drainage, slope of the terrain, depth of the soil horizon, texture of the soil, that is whether it is sandy soil, that is sandy, silty, loamy soil, what is the texture, then whether it is saline soil, then what is the nature and extent of the salinity, then the reaction, that is the reactions of the soil or the reaction nature or the characteristics of the soil. All these things can be identified by utilizing the technology. So this soil parameters, so this is a two-way process, that is scientists know that is these are the areas, but they don't know much about that, and this sample collection entirely depending upon the scientific community or the researchers, they cannot go into every field, but in a mutually benefiting way, that is farmers are getting their samples to get analyzed, and the scientists can utilize that data in order to make the soil atlas or whatever it is, so that in future they can utilize that, or the information will be passed over, or that will be given back to the farmers themselves also. Then in the website it will be that is what are all the areas, it will be mapped and it will be shown in a village wise map or panchayat wise map. It will be shown what is the what particular area, what is the ward number or village number, then what type of agriculture can be practiced here, what is the nature of the soil, what is the chemistry of the soil, so what type of crop can be grown in this particular area, what should not be grown in that particular area, what type of crop in what particular season or in what particular period of the year. So everything will be displayed displayed in the websites which are created for this particular purpose. So in this way, remote sensing and GIS technology is very much beautifully utilized. And then in a further step, the soil health card for individual farmers, that is, soil health means the soil health card for individual plots or the individual areas, that will be created. So how that is created is just by that is, we have seen that the soil analysis, the soil chemistry has been identified, soil chemistry has been done, that is the chemistry chemical analysis of the soil has been done, and that soil health card is created and that is given to the farmers. Then survey number wise soil fertility map is being created, that is survey number wise soil fertility map. That means there is black soil that may be good for cotton, but that may not be good for any other crop, and some areas which will be good for paddy may not be good for wheat, or some areas which may require good amount of groundwater, or which some area which may be lacking large amount of groundwater, farmers may be utilizing that land parcel for sugarcane, so that is not advisable. So survey number wise soil fertility map will be given, or that is being prepared and shown to the farmers, or they can utilize that. Then calculation of crop wise fertilizer requirement, that is another area, that is what type of crop is being developed in an area. So what type of fertilizer is required, on the same amount of fertilizer may not be required for different crops. So what is the nature of that, what much amount is required, so that will be passed on to the farmers. Then survey number wise horticultural map, is also created, and that can also be followed by the farmers. Then allocation of horticulture scheme, that is the allocation of horticulture scheme beneficiaries to farmers through WebGIS, that is another area, that is horticulture scheme beneficiaries to farmers through WebGIS, that is web based GIS is utilized. So why that is, we may feel that why web itself is enough, we may feel no, that is why GIS is required is we are utilizing all spatial data. Each farmer is identified with his own plot, that is the map is there, so it is for that particular plot, that particular land holding. So that will be it can be viewed through the WebGIS alone. So with that, so this is how we are utilizing this technology, that is the WebGIS is must for that. So in this way we will be utilizing the technology of remote sensing and GIS in agriculture. So just like we started, that is why we have just in a decorative way we have told that is sow and reap digitally. So digital means are available, only thing is that we should have a determination, the scientific community, the administrators and all, we should have a determination that the technological development will be passed on to the farmers, so that they will be benefited, and the farmers will be far more benefited because their effort will be that is taken care of in a very good manner, so that can be helping the country for sustainable development. So with that we are winding up this session. We will be meeting soon with another episode. Thank you for watching.